Okay, this is a little video to show you how to build the 4-pole CW filter. To start off with, you'll need a baseboard of some sort. You can use a piece of perforated matrix board like this, or today I'm going to use a piece of ordinary single-sided copper-clad board. I've actually drilled a few holes in this already. Make sure when you're handling this stuff your hands are nice and clean and dry, not greasy. I've actually polished this one up with a bit of wire wool to make it nice and shiny, and as a first step for building the filter I've laid a big fat line of solder all down one side of the board. Okay, the next step is just to apply some solder to the case of the crystal. Now you've got to be careful that you don't overheat the crystal, so don't leave your iron in contact with the crystal for more than 4 seconds. So clean your iron up nicely to start with. Apply a tiny bit of fresh solder to your tip of your solder of your iron, and that will enable heat transfer. Align your iron nicely to the crystal to enable maximum heat transfer, and then just feed some solder in. We just want some solder on this bottom edge here, along this corner here. Okay, that job's done. Do all 4 crystals the same. Okay, the next step is to solder the crystals to the board. If you just lay them out, it gives you an idea on how to centralise the crystals lengthways on the board, and that's somewhere near about right now, I think. So we'll take those off, so they're just standing there for the second, and this is how we solder the crystal to the board. Basically just heat up your fat line of solder that you've already created, and also the case at the same time. Run the iron in there. I can feel the heat coming through the case into my finger, and there we are. It's soldered in place. It's firmly attached. It's not going anywhere. Do the same for the rest. Just butt the next crystal in, line it up, heat the solder on the board and the crystal at the same time. You feel the heat transferring through. It's soldered in place. Carry on for the rest. Okay, the next stage, when you've got the crystals all attached to the board, is then to start linking them up. And basically all I've done is taken the leg of one crystal, looped it around the leg of this crystal here, and then just crimped it shut with the pliers like that. Okay, so now you can go ahead and solder those. Got to leave yourself enough room because you're going to have to attach the capacitors, so don't make these connections too close to the crystals. Okay, so that's the connections made. You can start trimming off the excess that we don't need. You can trim off the excess. Let's use the cutters. Just take those out like that. Okay, and the next stage then is to attach the capacitors. Now you have to refer to the circuit diagram because not all capacitors are the same value. I've shortened the legs of this one a bit and tinned it to make it easier to attach to the board. Got to make sure that none of the crystal legs or the leg of the capacitor other than the ground leg actually touches the board. Okay, let's just straighten that one up a little bit. Fresh solder. Okay, there he is in place. Okay, so he's not touching the board other than the ground leg. And you carry on with the rest of the capacitors. Apart from the ones on the end. I'll show you how to solder those in a minute. What I've done here is I've prepared a capacitor already, made a little hook on his legs. Move that out of the way. Moved a little hook, made a little hook on the end, and already pre-tinned it with some solder. What I'm going to do is just attach it to the leg, hook it around the leg of the crystal. You probably can't see because I got my hand in the way while I'm working, but you'll see in a second when I've got this thing soldered in place. Okay, there we go. So I've just attached the last crystal on there. The last capacitor on the end there now to the leg of that crystal, and we can chop off the excess. Now, I don't like things flopping around and shaking themselves loose, so what I need to do is anchor the leg of this capacitor firmly, but it needs to be insulated from the board. And what I actually do is a little technique I've got. Let's see if we can get this on the film here. I have a small piece of, tiny piece of PCB material, a little bit of copper clad board that I've chopped off into a little square, and if you can see, I've put a saw cut notch through the middle of the board, and that basically now gives me two pads that are isolated from each other. Now I solder one side of the pad to the board, and the leg of the capacitor will go to the upper pad, so it's totally insulated from the board. Now you can lay it flat on the board, but then that does produce a capacitor in its own right, so I tend to stand mine up vertically. Certainly it's only a couple of picofarads, I know, but I'm a bit fussy, so I make mine stand vertically, and I'll do that next. One thing I forgot to mention, it does help to pre-tin the board to make it easy to attach. So we'll, whoops, it's stuck on there. So we'll pop a little bit of solder on there to start with. Okay, so there we go. So it's pre-tinned, ready to attach to the board. Okay, I've worked out where I'm going to put this little isolated pad. I'll pop a bit of solder on the board to start with. And then I think, to save me burning my fingers, I'm going to have to hold this with a little pair of pliers, just so that I can attach it to the board comfortably. Okay, I'm deciding where I am in relation to the capacitor. You can't see too clearly, but you'll see now when I got it soldered in place. So keep the board vertical on the main base board. Okay, so there we go. If I can tilt that now, you can see she's attached. I'll just move that up. That capacitor's not yet soldered, but it will be. It'll be soldered to that upper pad. I've got a lot of leg length there, so we'll shorten that up, chop it down a little bit more. Still a little bit long. Now, this stage it's easier to keep the board sideways, because to stop the solder running down and bridging across the slot there. So I've got it in position. I've already pre-tinned it. There we go. It's attached now, and it's isolated. And now I can start going on to winding the transformers and attaching the transformer to this pad. That's the next step. Okay, the natural impedance of the filter is about 275 ohms, and what I want to do is transform that to 50 ohms to match my mixer and my IF amplifier that I've built for this for my radio. So we need to build a transformer. Now you need one of these little ferrite cores. Now what I've done is I've put a blob of paint on one side of the ferrite core. You can see the holes there. You can just about see the holes there. On one side I've put a blob of paint, and that's indicative of which side is going to be the ground leg. So that leg there will be the ground leg. Now just for these purposes, to make it clear to see what I'm doing, I've used a piece of PVC hookup wire here. So up through one hole and back down through the other hole counts as one complete turn. So as that stands there, that's got one turn on it there. Okay, now we need to cut off a length of enamelled copper wire that I've supplied. Probably something in the order of 250mm to 300mm of wire will be sufficient to wind the transformer. Okay, so strip that off there a second. Okay, here's my enamelled wire. The camera's having a struggle trying to focus on it. Okay. What we'll do is we'll put it through that hole there, and this is going to be, remember, the earthy leg. So what we'll do is we'll bend that just a little bit out of the way. So you've got about 20mm or 25mm poking through the transformer. Now you've got to start winding the transformer. You might not be able to see this clearly on the video because it's very, very fine wire, but each turn you need to pull it nice and snugly every time you go around. So that's one complete turn now. I've gone around, up through one hole, down through the other. That's one turn there now, and we need to keep this nice and tight. We don't want any slack loops, as you can see for the moment, but when I do the next turn, that little loop on the end there, that will disappear. I'll pull it nice and tight. Okay, I've now wound three complete turns on that little core now, and I need to make a tap point for the 50 ohm tap on this transformer. So I'll now start to wind the 4th turn, but not quite finish it. So down through one hole, and it's difficult to keep this on the camera here, but there we go. I'm starting to pull that line nearly all the way through, but leave a little loop there now. Now what we're going to do is grab a hold of that loop and twist it. Okay, we're getting about 4 or 5 twists, and then you can continue on completing the turns. So, the camera's struggling to keep in focus here. Okay, so that's turn number 4 now, completed. Alright, carry on and do a total of 7 turns. So you will have a transformer that's 7 complete turns, and the tap point is at turn number 3. Okay, that's completed winding the transformer. Now what we need to do is trim off the excessive leg length I've got there. We're going to shorten it to about 20 mm for each leg. And the next thing to do is to burn off the enamel coating off the wire so we can solder to it. Now, this is pretty tough wire that I'm supplying in the kit, excuse me, and the coating is really quite thick, so you need to persevere, keep the iron on the wire, slowly start moving it up and down, and you'll see in a minute it'll start to burn off. It's making a little bit of smoke. What we're looking for is a nice clean wire, free from any nasty black lumps. So it's starting to work now, as you can see. You might see it. I don't want to go too close to the core, so we'll stay with about 4 or 5 millimeters away from the core. Okay, keep moving it up and down, feeding in a bit of fresh solder once in a while. What you're looking for is a nice clean wire without any black lumps. Probably can't see it on the video, but that's looking quite good to me. Okay, do the same for all the other legs, and also the loop as well, the tap point. Okay, the next step is to attach our little transformer to the board. Basically, remember that the white paint mark that we've got on the core, the leg that comes out of that side is the leg that's going to go to ground. The tap point for this design is 50 ohms, so that's going to be the output of the filter. Sorry, output, yes, the overall output, and then this other leg goes to the remaining capacitor that's attached to that pad on there. So I'll just go ahead and solder this now. Okay, hopefully you can see now that I've taken the leg of the capacitor, the loop, the little tap point, I've connected it onto another one of these little isolated pads here. So the pad's grounded there, but the notch is in the middle there, so the two are isolated, and that now gives me a firm attachment point to tap my piece of coax onto, and it's not going to put any stress on the transformer. Okay, to complete the filter, you just carry on in the same vein. Attach the last capacitor on the end there, on this end here, wind the transformer, and construct little isolated pads. Okay, that's the completed filter. All capacitors, all the transformers in, and the isolated pads for connecting the coax to, so there's not going to be any stress on the filter whatsoever. Might not look that tidy, but it works very well.